I'm very pleased to welcome Dr. Liam Herringshaw. I've known Liam for 20 years or 25 years now, from when he was doing his first PhD at Birmingham University.
My only PhD, I'm not.
Yes.
I'm not going to know.
First research I meant to say there, but his PhD, and then he's gone on to do research within a number of specialist fields since then, all in the paleontological field. I've got to say Liam's PhD was one of the coolest things of all the PhDs. He did Silurian Problematica, which I just love, but he's not talking about that tonight. Since then he's gone on to do lots of interesting things, and I'll let Liam give you a little insight into those as he goes through. At the moment he's just described himself as a geologist for hire, but he does run this, the Yorkshire Fossil Festival, and he works with a mate of mine up in Scarborough area for a company called Hidden Horizons, and he's still affiliated to the Lifelong Learning Centre, learning with York University. So without further ado, I'll hand Liam over to talk to us about some gems of the Jurassic Coast.
Thank you, Graham. It's lovely to... Well, it's the first time I've been in this building. I was trying to work out how long ago it was that I actually talked to the Black Country Jolsock, and it's a long time. I would think at least 10 years. And as Graham said, my PhD in Birmingham was on the strange fossils of the Wenlock Limestone, which mostly meant museum fossils from Dudley. So my first ever geology field trip as an A-level student in Leicester was to Wren's Nest, and then my PhD was centred particularly around fossils from Wren's Nest. So I'm always happy to accept an excuse to come back and visit. We actually didn't go to Wren's Nest today, but I know Wren's Nest quite well, so I'm quite happy to see some of the other geopark sites that I haven't had a chance to either visit at all or certainly not see for a long time. But as Graham says, I've been based in York now for 12 years, and I worked at I lost track really. I worked as a researcher at Durham University for a while, looking particularly at shales and mudstones, and particularly things that live in mud. That's probably the thing. My PhD in problematical fossils kind of moved into things that live in sediments and the fossils that they leave behind. So a lot of what I'll talk about from the Yorkshire coast sort of builds on that. But I always feel slightly out of my comfort zone. I'm really a Paleozoic paleontologist. My fossils are Cambrian, Ordovician, Silurian, maybe a little bit Devonian, a bit of Carboniferous. After that I get a little bit lost, and I spend all my time now on the Yorkshire coast in the Jurassic, occasionally the Cretaceous, and sort of feel like I don't really know enough about the fossils. So what I do is actually spend a lot of time looking at the trace fossils, the burrows and the structures left behind by the creatures that were living in these various, mostly marine environments. And so my gems of the Yorkshire coast aren't necessarily those that the fossil hunters and tourists are perhaps coming to the Yorkshire coast for, but they get plenty of attention. So I'm going to give you a bit of a sort of their virtual field guide to some of the places I'm interested in on the coast, and the sort of stories that they're telling us. We are actively, I'm not an academic really anymore. I was teaching at Hull University until 2020, and then I went freelance. I'm still involved with various research projects, so some of the things I'll mention tonight are linked to ongoing research. So to start very topically, keeping it very fresh, 1822, this is the first geological map of the Yorkshire coast, or the first detailed geological map of the Yorkshire coast. The Reverend George Young of Whitby produced this in conjunction with his artist colleague John Bird in 1822. So last year was the bicentenary of this study of the geology of the Yorkshire coast. I love the fact that the orientation of the map is not what we would now use, really. The north-south is kind of east-west. But it does give you quite an interesting view of, I look at the coastline differently by having it in this orientation. When I first used this slide, I was based at the University of Hull, so I've put Hull on the map. I live in York, so here's York. I've put Middlesbrough with a question mark because Middlesbrough didn't really come into existence until 1829. So the other kind of biggest town on this map now wasn't there yet. The iron industry didn't really kick off and create Middlesbrough until a few years later. But we will work our way, as we're only in the Jurassic here, we'll work our way from Teesside down the coast to Filey Bay, If I had enough time, I would carry on into the Cretaceous and then the Quaternary, but we'd be here a long time. So I'm just going to focus on the Jurassic Gems. You can see these bands of colour that were mapped on by Young and Bird. Of course, 200 years on, there have been various tweaks to this, but the basic structure still sort of holds up, of having an early Jurassic band and then quite an extensive, still early Jurassic section running round towards, I'll use the pointer, here's Whitby, so Whitby up here. And then we cross a geological boundary into the Middle Jurassic, which then really runs along the coast through Scarborough. Much of the North York Moors are Middle Jurassic. And then finally, a bit of the Upper Jurassic appears around Filey before we cross the Jurassic-Cretaceous boundary somewhere in Filey Bay. It's not actually exposed, but we can work out pretty much where it is. So that was their map. Now, to sort of break up the stratigraphy in a more modern sense, and what I'm going to talk about, the different locations that I think are particularly interesting. We'll start with the oldest rocks at Redcar and the Redcar Mudstone Formation. I've put early Jurassic. They are Hatangian, Sinemurian, and Pliensbachian. So there's 3 stages of the early Jurassic present in the Redcar Mudstones. They actually have a pretty big chunk of the early Jurassic and see very little attention generally. And then Staithes, some of you might have visited Staithes, quite a famous coastal fishing village, partly for its art community there, but also for its geology. Most people who have been there will have gone to inspect the Staithes sandstone, which I'll mention later. And then as we move sort of further along the coast, Runswick has the lower part of the Whitby Mudstone, Whitby itself, we get to the middle part of the Whitby Mudstone, and then Robin Hood's Bay and Ravenscar, we get into the upper part of the Whitby Mudstone Formation. And then, as I mentioned, we'll then hop into the Middle Jurassic, what's known as the Ravenscar Group, which expose on much of the coast around Scarborough, before finally finishing in the coralline oolites of the Upper Jurassic. So that's our kind of general stratigraphy. These numbers are the locations I'll use, and I'll keep trying to keep the kind of colour and number scheme going so you can keep track of where you are as we go through. So yeah, early Jurassic Yorkshire, the first place to start in terms of, I guess, both the northernmost town on the coast, but also the oldest rocks is Redcar. And it's a pretty popular summer tourist resort, but perhaps isn't really seen as being a geological gem. But the rocks here, as I'll explain, are really both important and interesting in telling us what was going on in the earliest part of the Jurassic. I guess for a bit of context, it's worth saying that at the end of the Triassic period, there was a big extinction event. We don't have any rocks in the Yorkshire coast that preserve evidence of that, but the early Jurassic rocks can give us some information on what was happening not too geologically long after that extinction event. And so Redcar, it was studied extensively in the 19th century, but then seems to have just stopped being regarded as geologically interesting for a very long time, which is a real pity, because it has, particularly at this time of year where a lot of the beach sand has been stripped off by winter storms. I was there last week, and it's the rocks at Redcar Rocks are well exposed, and you can see these are quite seaweed covered because this was taken in the summer when the weed had started to grow. But if you go there now, there's a very good set of beds that you can work your way through of the Redcar Mudstone Formation, and they are the earliest Jurassic rocks in northern England. So they're really the once you go beyond Redcar and further north, you don't have any Jurassic rocks any longer in England. There are some in Scotland, but these are some of the sort of earliest Jurassic rocks that we've got access to. So they are again important in this sort of story of what was happening after the end Triassic extinction. You can hopefully see that they're very repetitive. You get these very prominent ridges of the more sort of coarser grained, shellier horizons, and then the muddier interbeds weather back. So you get a very step-like pattern to it. People have looked at this repetition and interpreted it's probably being controlled by climatic cyclicity, so probably orbital cycles, the Earth's orbit, that's Milankovitch cycles that some of you might have heard of before. This is probably a sort of a broad, wet, dry cyclicity. But in terms of the basic rock types, what you've got here are absolutely packed full of fossils. And this is the place that some of the most common Yorkshire fossils, and these are fossils, so here's an example. This is the most famous specimen of Gryphea that I have. I say I have it, I can't find it currently. I took it on Countdown when I went on the quiz show many years ago. They bring some things in when you're on the programme to show us the things that paleontologist does. So I brought a few Yorkshire Coast fossils with me. So that Gryphea appeared on the telly, but now I can't find it. So you can tell my museum curation skills are not up to scratch. They're often referred to as devil's toenails. You might have picked them up. They're very common around southern England, and bands of these early Jurassic rocks stretch from the Dorset coast actually through parts of South Wales and then up through the Midlands and out to the Yorkshire coast. Because they're such hard little calcareous shells, they become very readily transported pebbles. So you find that Redcar has these beds of them, which are sometimes referred to as gryphites or gryphites, just beds of Gryphea. You can see this bed here is just packed full of these thick, curvy shells, almost all of which are these early Jurassic oysters, these Grypheas. But then the sea and ice have picked them up and moved them down the coast, and every pebble beach, pretty much from Redcar down to Spurn, has got Gryphea in it. They've almost all then been moved. It's only in Redcar and Robin Hood's Bay that you've got the actual beds with them in it, but because they're very readily transportable pebbles, they pop up everywhere. So I say to people, every pebble beach on the Yorkshire coast, there's a chance you'll find Gryphea. Most of them won't belong there. They'll have been moved by ice or by the sea or both. So it's a very kind of distinctive fossil along the coastline and inland as well. It pops up in various ice age deposits across Yorkshire, south of where the beds are exposed. And say in the 1870s, these rocks were studied quite a lot of detail. It wasn't until 2020 that anybody else really had a proper look at them. So it's an enormous gap. The Redcar mudstones are also found in Robin Hood's Bay. People had studied them there, but in Redcar itself, it wasn't until Jed Atkinson from Leeds University and his colleagues, in 2018, you may remember the beast from the east, a big easterly storm came in. The Yorkshire coast beaches were stripped of almost all their sand. So for geologists, there was a sudden opportunity to get in and see beds that weren't normally exposed. And Jed and colleagues saw that the Redcar rocks were really well exposed. They went in and logged and sampled and built up a detailed picture. And although Gryphea is the dominant body fossil that we see, they actually show there was a lot of other things. There's various types of ammonite. There are various gastropods. There's a little one in cross-section. Bits of crinoid, sea lilies. I think another common bivalve here with borings in it. You can see. So some of them you find they were bored geologically. We can show the borings are filled in with the same rock fill, but they're also quite often modern surfaces that creatures will live on and bore into. And what Jed and colleagues really showed was that there's actually quite a diversity of fossils in the Redcar Mudstone Formation in these earliest layers, the earliest part of the Jurassic exposed on the Yorkshire coast, and they interpret it essentially as showing that by the time those rocks were formed, probably 1 million or 2 years after the end-Triassic extinction, that the seafloor ecosystem was pretty diverse, that there was a wide variety of things living on and in and above the seafloor. So by that time, the Cleveland Basin, the sea that covered Yorkshire at the time, had what we perhaps consider a fairly normal marine ecosystem. So we don't really see the extinction interval in Yorkshire, but Jed's work shows that by this point things were fairly kind of normal in a Jurassic seabed fashion. If we then move a little bit further east, and there actually are a number of places you could stop, but Staithes is a good place to explore the next unit above the Redcar mudstones. This is a geological map that Ian West, who, if you've ever spent time on the Dorset coast, has produced an extremely detailed geological website for the geology of the Dorset coast. The one bit of the Jurassic Yorkshire coast that gets covered is the Staithes area. And this is probably because it's a classic field location that students get taken to. I think possibly partly because it's one of the few places where sandstones are exposed, and mudstones are, at least in my experience, often regarded as too boring to take students to go and look at in detail. That is a terrible error, but it does happen quite a lot. It's just a grey load of mudstone. We're not going to go there. Let's go somewhere with a bit more sedimentary structure. And the Staithe sandstone around Staithe Harbour do have some wonderful sedimentary structures. So I think people have often gone there to do a bit of initial field training. And then if you walk east from Staithes, around Penny Nab to Old Nab, you get into the Cleveland Ironstone Formation, which is the unit above the Staithes sandstone, and obviously then get different lithologies, different rock type structures and fossils to look at. So if you do a trip that starts in Staithes and sort of finishes in Old Nab, you can actually do quite a variety of sedimentary geology in a relatively small area. You do have to be very careful of the tides, though. It's a place that will happily cut you off without warning if you don't know where to go. So this is what Staithes Harbour looks like. So if you were to come down into the village and head down to the beach, the Staithes Sandstone Formation is exposed here in the bottom of the cliff, and then the Cleveland Ironstone forms most of the sort of upper part of the cliff, and essentially you then kind of follow your way round and head sort of east, southeast along the coast round the corner towards, ultimately towards Whitby, I suppose, to start looking at the overlying ironstones. As these signs here give you a clue, there's a person wisely wearing a hard hat. These are they're very, for the Yorkshire Coast, they're very tall cliffs, and they are the sort of cliffs where a lot of material does come down regularly. So these signs try and remind people that if you are getting up to look at these rocks, please do wear appropriate headwear, because bits do come down quite frequently. But if you can ignore the sign temporarily, you can hopefully start to see that in these layers of sandstones, you can see there's these kind of gently swaly looking cross beds. So there's wedges of sandstone here. You follow the layers, they kind of go up and down, and then above them, they're more sort of flat, muddier, and occasional flatter sandstone layers. These intervals in here are taken as storm beds, and the hummocky shapes, hummocky cross stratification is taken as a classic storm wave deposit, where big waves were agitating, moving sand backwards and forwards, producing these structures. They don't have any fossils in them, but the layers above do tend to be. You actually see there's a shell bed running through the top of the picture here. Lots of material. We think actually a lot of these units on the Yorkshire Coast, storms are a big part of what is fossilising the shells. So those gryphea-rich beds are almost certainly where big storms have just buried a lot of shells altogether. You often find a kind of an orientation to the shells that they're sort of resting in a stable orientation, but not, they can be a bit mixed, and then they tend to fine upwards. And the same thing happens here. You tend to get these sandstone beds, and then they fine up into muddier material. The muddier material loses all of its structure pretty much because of burrowing creatures. So I mentioned trace fossils and burrowing creatures. There's a lot of places on the Yorkshire Coast where we can actually start to look at life in the seabed. And the Staithes sandstone is one of those. In essence, you've got a battle between physics and biology here, that the physics of the waves is producing these cross-bedded structures. The sands have very little nutrition in them. Sand is not a good thing to eat generally. I know kids on the beach sometimes sort of shoveling in sand, but it's not generally a good foodstuff. But the muddier material that was deposited on top of the sands is often then full of things that might be of greater nutritional value. So you tend to find in these sorts of packages, the sands are undisturbed, they're not burrowed through because there's not really much in there for burrowing creatures to exploit. But the muddier layers are much more churned up, because once the storm had passed by, there was then a layer layers that these creatures could come in and start to exploit. So you find when you look in close up, there are lots of tubes and blobs, and the pattern is, rather than having nice clear flat layers of sort of physically moved sediments, you've got mud and sand all mixed up and churned up, and this stuff has been really bioturbated thoroughly. The particular thing that's got a name here is this little burrow in here that is a very small burrow with a very long name. Schaub cylindricnus is one of these sand-lined tubes that's quite common in the muddier layers of the Staithes sandstone. And I worked in Canada for a couple of years as a postdoc after I'd done my PhD. And I got to Newfoundland where I was working, and I said, right, where's the first place we're going to do some field work? Thinking it would be, somewhere excitingly Canadian. And they said Scarborough. I know there's a Scarborough in Ontario, but no, they meant Scarborough, Yorkshire. So my first field trip, having moved to Canada, was to come back to the UK and start looking at the trace fossils in the rocks around Scarborough. But a reason for that is you get an amazing variety of different fossilised burrows in the rocks on the Yorkshire coast, and they've not really been buried and altered a great deal. So the fabrics are very clear. And what I and various colleagues were trying to do was to understand the sorts of things that these organisms were doing, what these creatures were doing, even though they themselves are not fossilised. So we had a number of projects going to different locations, collecting distinctive trace fossils and trying to then characterise them. In some cases, that did involve slowly destroying the blocks, taking a sample, grinding away, photographing and building 3D models from the photographs of what the structures were like and what they were doing. And then trying to interpret what might have been producing. So this has clearly got this sand, it's a tube with a sand lining. What might the creature that made it have been doing? Jill Evans and Supervisor Duncan McIlroy wrote a paper a few years ago to sort of say, well, this is one of the things we think. When we look at something like Shabsel in detail, we find actually there's lots of little layers to it. And it looks as though the creature is sort of systematically working its way, sort of, I guess, deposit feeding, kind of mining its way through the sediment and backfilling sort of a tubular burrow as it moved along. The sand would be material that was of no real nutritional value, so kind of get rid of that, eat the mud, and then excrete at the other end and just keep moving. It's just like a little conveyor belt almost. And a lot of worms essentially do that kind of thing in muddy or mud-rich sediments. They will systematically process sediment, chuck out the sandy material, or maybe use it to line a burrow. One of the reasons that they might also line the burrow is that if you have got a sandy lining, that can help if the animal is irrigating. So you live in a burrow for any length of time, they'll tend to irrigate and flow water through it to keep it oxygenated and keep it habitable. But it might also mean that you can actually flow material through the burrow and both flush things out, but also grow things. In some cases, we think some of the burrowers are actually using the linings of their burrows to kind of garden. In this case, for Shabsel inductus, that's not what Jill thought was going on. She just thought they really deposit feeding. But we find that the more we looked at the burrows, the more different stories we started to get. So yeah, not something most people coming to the Yorkshire Coast were really looking for, but I think they've got interesting stories to tell. Old Nab is then the headland that really exposes the Cleveland Ironstone Formation. The unit sits on top of the Staithes sandstone. And as the name tells you, it was the source of much of the ironstone in the Teesside and Cleveland region. It was particularly extensively mined in the 19th century. It was still being mined until the 1960s. The last Cleveland ironstone mine shut down in the 1960s. The Land of Iron Museum is just about what used to be the Skinning Grove Cleveland Ironstone Museum has just had a big revamp and is about to reopen as the Land of Iron. So we can look forward to seeing what their stories they've got to tell us there shortly. Apparently they're going to put lots of the Jurassic Sea creatures, the big exciting dinosaur-y type things on display. Sadly the burrows don't bring the audiences in, so they won't get much of a feature. But you can see here, this is not a natural landscape. So you can see the layers, very, very horizontal really, but all this has been quarried out. So along a lot of the Yorkshire Coast, people now would say, oh, lovely landscape walking on. It's all industrial. Almost every bit of it has been exploited in some way. And at Old Nab, all of this has been dug out for ironstone extraction. And there's a lovely burrowing link in here, because if you go to Old Nab and walk around this part of the old mine, you'll find on the flat surfaces these sorts of structures, big long tubes that come around in a U shape. They're cross-cutting. Most of them should have this kind of roundish bit, and you can just about see inside there are little layers that cut across. So there's not just a single U shape, actually it's a U shape that's kept moving position. The name given to these is Rhizocorallium, which means root coral, and they're neither roots nor corals. The name has no value in its description at all. It relates to the fact that people found these structures often in the rocks and were like, well, what is this? It's not a body fossil, obviously, or maybe it is, maybe it's a root or something else. So the names are often quite speculative. A lot of trace fossils got given names relating to plants because people thought they were maybe seaweeds or roots of some kind. And we now know that the vast majority of them are just structures that were produced by different animals in the sea floor. If you look carefully at these Rhizocorallium, you can see they're quite scratchy looking. The texture is not just smooth. You can see there's lots of little sort of lines and bumps all the way along the burrow structure, so in each of these. So you can actually see that the creature that made them was digging its way through a firm sea floor. It was almost like plasticine, something sort of muddy but firm that they could dig through. And as they did so, they left behind these distinctive sort of scratch marks. For a long time, people assumed that they were made by crustaceans, so things like lobsters or shrimp or something with claws kind of digging their way through. However, Dirk Naust, who is a geologist, German geologist working in Norway, had a closer look at these and realised that in places you'll find fossilised poo. There are in layers in the burrows, you can work out what the creatures who lived in it were excreting within the burrows. And when he compared these, he found that some of these rhizocorallium structures have fossilised coprolites in them that basically look like polychaete worm poo and not like crustacean poo. So he thinks actually a lot of these were not made by the claws of crustaceans, but the jaws of worms digging their way through. It's still argued a little bit about, but it's certainly suggested that there's more than one possible interpretation. And of course we never, or almost never, find the trace makers fossilised in here. The other thing I really love about these rocks, these fossils, is that you can see that the ironstone is actually kind of filling the burrows. So the burrows, of course, would have been hollow in the mud. They've then acted as conduits through which iron-rich fluids could flow during burial, and the ironstone has become concentrated in the burrows. So the Cleveland ironstone miners were mining the mines of Jurassic sea creatures. There's a lovely sort of circularity of what was going on. So yeah, they may not be roots or corals, they may not even be quite sure whether they were worms or crustaceans, but they actually had an economic value inadvertently by concentrating iron in these burrows. So yeah, I don't think many Cleveland ironstone miners would have been although we do know they would find these things, and they had some quite odd names for some of them. There is a paper from the 1970s describing some of these fossils, and apparently the mining term for them was dog's cocks. So you could tell, there's academic literature that doesn't get a look in quite the same way there. But yes, the mining terms are very informative, and people never forget that once they've been told that that's the term. Now, if we were a little bit further along the coast, and we get round to a bit closer again to Whitby, from Staithes, we carry on to Old Nab, we get into Cleveland Ironstone Formation. We can carry on a bit further around the coast, and the next sort of major bay is Runswick or Runsick, depending on your preference. It's a bit like Keswick kind of pronunciation. Some people in the area lose the W, some don't. So I get into arguments about which is the correct way. Either way, it's a really fabulous place to go fossil hunting because the beach has lots of ice age erratic pebbles on it that can be full of fossils. And then it has fantastic Jurassic exposure, which is full of fossils. So you can sort of do two kinds of fossil hunting here. It also happens to preserve a mini extinction event, which has been of research interest for quite some time. So it is quite a steep place to get to. I'd say testing your car's brakes and general suitability is worth doing before you go to Runswick Bay. There's a car park down the bottom, but getting there is one thing, getting out again is another. I did see last summer a coach drive down, and people were there's a big sign saying no coaches beyond this point, and the guy luckily had a modern enough coach with enough power to kind of 93-point turn at the bottom and get back out. But I've seen vehicles look like they're going to stay there for the rest of their short remaining lives. We're going to head down the path and then round into the southern part of the bay. The village of Runswick Bay, not many people actually live there now. It's really a holiday village. That's the old Coast Guard's cottage, which is the last surviving building of a 19th century or 18th century landslip that took out all the rest of the village. Essentially, there's a load of Ice Age clay plastered to a fault, and periodically the whole thing slides. So we often warn people that there's a chance of landslips in the bay. If you safely get down to the bay, you're fine then to explore. There's some Middle Jurassic sandstones at the top of the cliff. Difficult to get to. We tend to focus more on the lower Jurassic stuff at the bottom of the cliff. If I went around this way, I'd go back towards. I was just talking about Old Nab and the Cleveland Ironstone, but we're instead going to go the other way, where the Jurassic exposures get better and better. Just to quickly kind of make sure that you've not completely lost where we are. So we had, say, Redcar Mudstone. Staithes sandstone's not very thick. Cleveland Ironstone Formation actually isn't enormously thick. Then we hit in the Whitby Mudstone Formation, which is quite a decent thickness. You can see here there's 14 metres, 31. You've got sort of, what's that, 68, 80, about 80 metres or so overall thickness of that unit. In Runswick Bay, we can get the top of the Cleveland Ironstone Formation and then going into the Whitby Mudstone through much of it, actually, if you walk along the section. Here are all the ammonite zones, if you're an ammonite person. One of the things you spend a lot of time looking for is the diagnostic types of ammonites. They change very regularly, so it's very useful for knowing where you are. And as we cross the Cleveland Ironstone into Whitby Mudstone, we're kind of crossing the Pleens-Bacchian-Toarcian boundary. And the Toarcian stage is a stage that's now known across the world as being an interval where climate change and extinction has been observed in the marine, particularly the marine mudstones. So there's the headland of Kettleness in the distance through the low cloud at the south end of the bay. That again is an alum, or it's industrial, it's an alum works. They're digging out the alum shales, which I'll talk a bit more about in a moment. So again, this is not a natural headland feature. It's been extensively quarried, and if you go to Kettleness village itself, it's like a lunar landscape. It's so extensively dug out. It's often known locally as the sleeping dragon. You can just sort of imagine the head and the neck, or sometimes even Crocodile Rock. I hadn't heard the Crocodile Rock name for it until we were there just before Christmas on a little fossil hunt, and we literally picked up a piece of Crocodile Rock. I have never done this before. I'm not a vertebrate paleontologist. Most of my expertise is in, in invertebrates and burrowing things, but we were walking on the beach, the two of us together kind of went, oh, that's an interesting looking block. Oh, that's bone. Oh, it's got, and these are eye sockets here. This is the kind of the top of the skull. This is the underside of the jaw. Weirdly, this part looks more crocodilian, even though that's the underside of the jaw. And yeah, there it was, just sitting on the beach. It's a nodule that Macy, who was, she wants to study paleontology. So I said, well, there you go. You've got a dissertation project for when you're at university in how many years' time there you can resolve what kind of crocodilomorph, but it's not strictly a crocodilomorph it was. But the Whitby Museum has a beautiful specimen of a complete one that was found, I think, in the alum works at Kettleness 200 years ago. So hopefully she'll get a chance to go and chat with the curators there and find out more about what exactly she's discovered. But the trace fossils are far better than, marine reptiles. Who's interested in that sort of thing when obscure burrows are the good stuff? But yeah, what we can do here, we can walk around to the southern end of the bay. We hit the Whitby Mudstone Formation. Basically, it comes in at the bottom of the cliff, so that what I'm standing on the beach is the top of the Cleveland Ironstone Formation. So we've got the kind of boundary between these two units. You can see when you get your eye, and there are little vertical shafts in here, little columns. This is actually a filled-in jet rock mine, so all of this is kind of rubble that's backfilled. So 19th century, when Queen Victoria's mourning mourning clothing and mourning jewellery led to a real surge. I mean, Whitby Jet has been exploited for a long time, but 19th century went really big because of Queen Victoria wearing black a lot of the time after Prince Albert had died. That jet rock mining became a really big business. It's still active to some degree, although I don't think anyone's going up and digging their way into the cliffs. That would be a very foolish endeavour. Most people just wait for this to wash out onto the beach and then pick their way through. Spoiler alert, Whitby Jet is not just monkey puzzle tree. So people always get told, Whitby Jet, it's monkey puzzle tree. There's Sarah Caldwell-Steele's doing her PhD on Whitby Jet at the minute, and there's a whole variety of conifers fossilised as jet. So it's not just one type of conifer, the monkey puzzle tree that we perhaps know today. There's actually a variety. So anyone that tells you about jet, it's not just monkey puzzles. So there you go. There's a paleobotany spoiler for you. If you get close up to the rocks then in this part of the coast, you can see, so this actually, although it's not very iron rich, this is the top of the Cleveland Ironstone Formation. And you can still see in here that the layers are a bit churned up. So this is clearly still being burrowed quite a lot, because the sort of the original sedimentary layers are rather mixed up, and it's got this kind of chewed up looking fabric. And then we quite abruptly hit a layer which is not disturbed, and then we get a whole stack of layers which are increasingly very dark, very organic rich, which have almost no signs of disturbance. And then towards the top we start to get a few more things coming in again. And this is part of an interval where we now think there was a significant phase of warming, probably driven by volcanic eruptions in South Africa. The Karoo igneous province was starting to get going in the early Jurassic, and it suggested that the amount of CO2 being erupted caused a significant warming of the Earth. And in shallow marine basins, a lot of stratification of the water, so both sort of a mixture of fresher and saltier water, but also warmer and cooler water, basically started to, the oceans were getting less and less pleasant to live in. So we have, Plene's Vacuum, which is to say essentially the Cleveland Ironstone Formation, and then we begin to get into the Toarcian the next stage where we get a lot more of this organic rich. And it's known as the sulfur band because when you get a piece of it and look at it closely or sort of smell it, it has quite a sulfurous look, a sulfurous odour to it. So this is actually a kind of marker along the coastline. And it really represents the beginning of this sort of phase of global warming and reduction in the abundance of creatures living, particularly on the sea floor. So here again, the trace fossils are a key part of this, because if we've got trace fossils, we know creatures were living in the seafloor, in the sediments. We can say if there are burrows fossilised, we know that they were there. So as we go through the succession, one of the things we're often looking for is, are there signs of bioturbation? Because that will give us a fair idea of whether things were living in the sediment, and that may tell us what the sediment conditions were like. We, of course, shouldn't just treat it on its own. We need to think about what other things are around. So things like the bivalves, the oysters, the devil's toenail sort of relatives, are they around, and what are they doing? Are they burrowing? Are they sitting on the seafloor? Can you kind of combine the information? Here, what we've got close up on this level is Rhizocorallium. So the one I mentioned at Old Nab, it's a different preservation, but again, you've got a sort of U-shaped burrow with these little lines inside it. So it's something quite similar, albeit in a slightly different rock type, to the ones we saw in the ironstone at Old Nab. But we also get vertical ones, Diplocriterium, which are the same sorts of burrows, U-shapes, but the Diplocriteriums go down vertically, the Rhizocorallium go horizontally. It turns out, actually, they sometimes do both. So you get ones that start vertically and then become horizontal. And it may be that those burrowing creatures that came in this layer higher up, were getting down to a certain level that either was too firm to burrow into, or was just too unpleasant and too sort of sulfur rich or organic rich, and they went, oh, it's fine here. Oh no, I don't like it anymore. I'm going to go horizontal. So we get a kind of a change of shape. But what's really significant is this bed is the last bed in the Whitby Mudstone Formation with burrows in it for at least 600,000 years. And it may be as long as 2.5 million years, depending on how exactly you try to define the age of these, or the duration that these very organic-rich jet rock beds were deposited in. It isn't yet available, but my friend Bryony Caswell at Hull, who I used to work with when I was at Hull, she and I have just had a paper accepted that basically combines the burrows and the bivalves to try and tell this story. That essentially the seabed in the early Jurassic had recovered from the Triassic extinction. We had lots of diversity, and that's through the Redcar Mudstone, through the Staithe Sandstone, through the Cleveland Ironstone, and then there's a massive drop-off in diversity. An extinction event had already been described, but what we've sort of said is that actually there's no burrowers, there are no signs of bivalves going into the sediment for a very long time, and it seems that the ecosystem just really sort of shut down. Whether these burrowers went extinct or whether they move elsewhere, we don't know. Occasionally, these sorts of fabrics are found in other parts of Europe in layers that are equivalent to the jet rock in Yorkshire. But essentially on the Yorkshire coast, we have the sulfur band, this lower unit down here, and then the burrowing horizon, and then nothing after that except thinly layered black shale, which is great for fossils like jet and ammonites and marine reptiles, but no signs of burrowers or things on the sea floor. So then we get to Whitby, which I'm not going to sort of make a huge use of in terms of telling the story, but Whitby, as you would expect, is where the Whitby Mudstone Formation was defined. And it's also where we're going to have the Fossil Festival in the summer. So if you are in need of something to do in June, we're going to take over the Whitby Museum, Panet Park area, and hopefully other parts of the town in a fossiliferous fashion for a couple of days, and it's all free, so you can come along for a weekend in Whitby and enjoy more of this kind of thing, and perhaps explore the Abbey. Beneath the Abbey, so here's the Abbey at top of the headland, and then the East Cliff has a lot of the Whitby mudstone exposed in the wave-cut platform. This is the ammonite that's named after St Hilda, the abbess of Whitby Abbey, so Hildoceras bifrons or bifrons is one of the distinctive ammonites. There are many others, the Dactylioceras ammonites and various belemnites, but these guys were all swimming about. So they don't tell us what life was like on the sea floor because they were mobile. They could swim out in the water. It could have been horrible down on the seabed, and oxygenated in the upper parts of the water column, and after they die, they get buried and they don't get disturbed, and they do get fossilised. What we're interested in really are things like these little bivalves. If they're present on the seabed, maybe they can tell us that conditions were, at least periodically, okay. So most fossil hunters are there looking for the lovely, well-preserved ammonites that have settled down and been preserved in essentially very low oxygen conditions. But I'm interested, and Bryony's interested in where things that lived on the seafloor are present. And this is one of my favourite Jurassic Yorkshire fossils, Pseudomytoloides dubius. Pseudo meaning false, Mytoloides meaning a bit like a mussel, and dubious obviously meaning dubious. So the dubious false, a bit like a mussel shell. You can tell they were hedging their bets about its affinities. It's not really anything to do with modern mussel shells, but it is a bivalve, and it's very noticeable in the jet rock, in the very organic-rich parts of the Whitby Mudstone Formation, because it'll be the only shelly fossil that was living on the seabed, and it looks like it colonised the seafloor in brief oxygenation events. So there were probably short, maybe months, years, where the seafloor was pleasant enough, but it can't have been particularly good because there's still no signs of burrowers or other things. It's like one species comes in that was able to tolerate this. This is actually an image from a mine that's being built near Whitby for potash mining. So you've got a 23 centimetre core with a few of these pseudomytoloides, and we were looking at the core and finding various levels where these things were the only creatures there, or certainly only sea floor creatures there. And it's the same on the coast. If you were to explore the coast, you'd find layers of these beautiful sort of flat, slightly fool's gold bivalves, along with other things, but only things that were swimming around. So we have also published on this recently. This paper is out. You can go onto the Proceedings of the Yorkshire Geological Society, and it's an open access paper. The mine near Whitby that's drilled down through the Jurassic rocks to get down to the Permian potash very kindly let us have a look at the Jurassic cores. And the really useful thing there is that what I've been showing you so far, you're having to do a piecemeal story, going from place to place along the coast and build up the picture. In these boreholes, these cores, you're in one location where the borehole then gives you a continuous succession. And João Trabuccio Alexandra, who's a lecturer at Utrecht University in the Netherlands, he led on this study. We were working at Durham together for a while. And the story is still fairly similar to the rest of the coast, but we did find a few subtle differences that show there are lateral changes. But the key thing was it seems to have been quite stormy. There is various evidence in the sedimentology of storm deposits, even in this very organic-rich, stinky kind of black shale, organic-rich mud. So it's funny to kind of get your head around this. It doesn't look like oxygen came in very often, and yet storms seem to have still been present. I still find it quite hard to sort of get my mind around the idea of storms not bringing necessarily much oxygen to the seafloor. But apparently in some modern settings in places like the Black Sea, that sort of thing can happen. So if you want to explore a bit more of that, you can read that paper. And then last bit of early Jurassic Yorkshire before we sort of move into the upper parts is the southern end of Robin Hood's Bay and Ravenscar, where we get the upper part of the Whitby Mudstone. We get the kind of recovery story. So again, it's a pretty steep. Here's Robin Hood's Bay. You've got these curving beds. These are actually Redcar mudstones. So as I mentioned, it's mostly at Redcar, but actually in Robin Hood's Bay, thanks to tectonic activity, there's a major fault that runs through Robin Hood's Bay in this sort of orientation, and beds of Redcar mudstone have been pushed up relatively, and that's this curvature, is they're curving into the fault. Robin Hood's Bay is up here, and then we have Staithe sandstone on the top. But behind me, on the other side of the fault, is all the upper part of the Whitby Mudstone Formation. To get there, though, you have to watch out for seals. This is my exciting risk assessment. One of the biggest grey seal breeding colonies on the northeast coast is at Ravenscar. And at this time of year, it's actually pretty dangerous to go there because there are so many breeding or nursing seals that you can either harm the pups or get attacked by the defensive parents. Thankfully, there's not so much vegetation at this time of year, so you can take a different route round to get to the sort of fossiliferous part of the coast. You can also go inland, and this is actually quite handy because in various parts of the Yorkshire Coast where there was industrial activity, there are old sort of quarry or dugout sites. Here at Ravenscar, regardless of what the tides are doing, we can get to see the upper part of the Whitby Mudstone, the alum shales, in some of these old quarries. So here we actually have the the uppermost parts of the Whitby mudstone, then what's called the Dogger Formation, which is this very tough sort of ironstone band on top, and then we get to the Middle Jurassic Ravenscar on top. And this means we can sort of see what's going on at the end of this period of climate change and ocean or seafloor anoxia. This is what it would have looked like when it was in full swing in the 19th century. And again, huge. This is the same. So this is the same quarry. This is, down sort of on the coastline. This enormous volume of rock was being dug out to produce alum particularly for fixative of dyes in clothing. And it's now a National Trust site. You can go and explore the old alum works, but it's, again, people see it now and go, oh, lovely natural landscape. No, it's almost all been dug out by people, and it's now just been vegetated over. Almost all the gorse grows on spoil heaps that are sort of through here, and you can find odd little bits of fossil in amongst the baked remains of the shales that they were processing to make alum. So, yeah, some odd chances to go fossil hunting. And the things to look for, and again, the local miners, quarrymen knew what to look for. There are these little shells called Dacrymia ovum, or nut clams. Someone say that the nut shell, they knew the alum shale because they would find these little nuts in there, and they knew that was the level to quarry out. But what Bryony and her colleagues showed a couple of years ago is that these represent the first burrowing bivalves going back into the seafloor. So it's one of a very limited number of species, but these sorts of things were actually living in the sediment. So we know by the time the alum shales came along at the end of the Whitby mudstone that things were starting to get back into the seafloor again after this Toarcian anoxic event. But it could be as long as 2 million years where really there wasn't anything much in the Yorkshire seafloor, at least. It seems more extreme in the Yorkshire successions than elsewhere, which is an interesting thing we haven't figured out why yet. Okay, so now we're sort of getting towards the last couple of bits, really. The Middle Jurassic, so this is Ravenscar, this is the end of Robin Hood's Bay where we were just talking about, and you leave the Lower Jurassic behind, and then we work our way down towards Scarborough in the Middle Jurassic, places like Cloughton and Burniston, great exposures of Middle Jurassic. It's a very different kind of succession. So having had loads of mudstone, we suddenly get loads of sandstone. So here's a view from Burniston looking down towards Scarborough. There's the Castle Headland, Scarborough. And all of this here is Middle Jurassic sandstone. And indeed, quite a lot of the cliff here is also Middle Jurassic sandstone. So there's quite a dramatic change from being marine mudstones to predominantly non-marine sandstones. It is thought that the northern North Sea underwent a phase of magma welling up underneath the North Sea and uplifting that part of the northern, what's now the northern North Sea, and the knock-on effect was to start to uplift that side of the Cleveland Basin and push it above sea level. So rather than being a marine basin in the Middle Jurassic, it becomes essentially a marginal sort of coastal non-marine basin. So almost all of this exposure here is of non-marine or predominantly non-marine sediments. If we get down the beach at Burniston, we can see there's more sandstone up here in the cliff, but quite a lot of sort of fairly flat-lying stuff. And you can see here some coal, or some almost coal. So there's a little bit of Jurassic coal. In one or two places it was excavated, but it was never very good quality. It was only really used locally. But you've certainly got sort of soils and river flood bank deposits, and then channel deposits. Much of the stuff down here is river channel deposits. So again, we've got quite a different story. This is the part of the coast often gets referred to as the dinosaur coast. You won't find dinosaur bones. People get very disappointed. They think, I can come to the dinosaur coast, I'll find dinosaurs. Sadly, no. The marketing has slightly misled you. What you will find are lots of dinosaur footprints. So almost never any bones, but as Mike Romano and Martin White Martin and Mike were at Sheffield University many years, they mapped out there are footprints in the Middle Jurassic much of the way down the coast, particularly around Scarborough and indeed in the North York Moors. And they're really very common. So you won't find bones, but I could take you out on any trip, particularly around Burniston, and we will find footprints. So here's my left foot on a student field trip with a large three-toed print in here. There are about 30 different kinds of footprint found in the Middle Jurassic of the Yorkshire coast, but almost no bones. So we don't really know what dinosaurs made them. But we know from equivalent rocks in Oxfordshire and elsewhere that things like Megalosaurus, Cetiosaurus, and sort of various large but not yet super-sized theropods and sauropods were around. the suggestion is that they were just coming to the Yorkshire coast for their holidays because they've just got the footprints left behind, which is a nice idea, 160 million years of Yorkshire coast holidays. I think it's probably a little more complicated than that, but let's go with that for the moment. We find lots of fallen blocks, and you'll end up probably, if you do this, looking at blocks of sandstone going, can I see anything in here that could be often the best footprints are where the creature was walking in quite firm mud and then the mud was cast by sand, and then the base of the sandstone is where the good structures are. We found this in Burniston a couple of years ago. There's quite a lot of fallen blocks with patterns and textures in here. Often depends on the light as to how you see them. But after a bit of getting your eye in, what you might start to see is that there are two. There's a little three-toed print here and another one. That's probably the best one. But these are probably diddy little dinosaur footprints. You can see the scale bar. Here's, so you're talking, what's that, 3 or 4 centimetres. That's a bird, really. And there are no dinosaur bones known of anything that small. So is it a juvenile? Is it a small type of dinosaur? These structures are probably crustacean traces. So these sort of chevron, curvy sort of shapes are probably the head shields of things, maybe like horseshoe crabs or something of that nature. And these little sort of ridges in between and the groove in the middle are probably the pairs of legs, sort of as they move their way out onto the sort of tidal flat. So whether the dinosaurs were small dinosaurs looking for food along the shoreline, there's no direct evidence of interaction. But again, might remind Martin White have described lots of non-dinosaur tracks, including horseshoe crabs and so on. So there's quite a lot going on that we've begun to, or people have begun to sort of flesh out. But we get stories of dinosaurs that we don't get any bones of and have mysteries as to what exactly they were. Sam Slater and colleagues from Sheffield wrote a paper a few years ago now where they looked at the plant fossils, which are very good in the Middle Jurassic, and sort of tried to combine those with the footprints and showed that if you look at you've got things like, here are the Oricariaceans, the monkey puzzle trees. Here they are sort of suggested growing in the uplands, lots of other conifers in the upland regions, and then lots of other trees, but none of these would be flowering plants yet. So you've got things like the Catoniales, which are sort of almost flowering plants, but not quite, and then various other sort of groups of things like ginkgos were around, lots of ferns and fern-like plants. So a real diversity of paleobotanical fossils, and of course the big herbivores seem to have been found particularly in areas where there was lush vegetation growing, and of course then the predators would be targeting that. So there seems to be a bit of a, perhaps unsurprising, an association. But people haven't really spent much time looking at this. There's still a lot we don't know about where the dinosaurs were living and what they were sort of doing, and how they were interacting, and how that changed in time and space. So if you want a dinosaur project, this is quite a good place to go. You can even do it in Scarborough. So there's the Grand Hotel. Here's some of the Middle Jurassic exposure. Here's a big sauropod footprint. So you can sort of see the layers here. This one's been squished. So you can see the layers here. There's just something's gone boop, straight through it and left this big bowl-shaped structure that's filled in with sand. It's probably the hind leg of a sauropod. We know that the big four-legged sauropod dinosaurs didn't have front and back feet that were the same. The back feet, it's almost more like us walking on four legs. Their back feet were quite elongate and their front feet were more like hooves. So the back feet tend to make much bigger structures than the front feet. And in the South Cliff of Scarborough Bay, you find a lot of these if you start to look. So yes, if you're on your holidays in Scarborough, you can do dinosaur hunting. But most people just walk past them, because why would they know they were there? So finally, we'll just leave Scarborough behind, go around the Middle Jurassic and into the last bit of the Jurassic succession. Well, I now call it Filey Brigg, most people do, but here in the 1820s, it was clearly Filey Bridge. I'm not sure where the bridge was going to, didn't go very far out, but it is a very tough ridge of Upper Jurassic rock that forms this prominent headland at the northern end of what's now Filey Bay, and that's probably the best place to go and see the Upper Jurassic. So we have Lower Jurassic, mostly muddy, Middle Jurassic, mostly sandy, Upper Jurassic, quite limey. So we've got the three kind of main types of sedimentary rock. So this is the Brigg here. All of this stuff on top is till. This is all glacial deposits. So as I'll explain, a lot of the structures we have in the Upper Jurassic rocks seem to be linked to big crustaceans burrowing and tunnelling their way through the Upper Jurassic seabed. But then the whole thing has been glaciated. And I think Filey Brigg's a really interesting place to go and do a bit of field work, because you've got an amazing variety of things in one spot. So if you're interested in the bedrock particularly, which is what I'm talking about, what you'll see, lots of layers of sandy and limey material. It's all Upper Jurassic limestone and sandstone. Most of the Upper Jurassic in Yorkshire is limestone. The Brigg itself is a really hard, tough wedge of sand. It looks like we're quite close to the shoreline, and in that particular part of it, sand was coming off some sort of landmass, not quite sure where it is, but some sort of landmass that was producing a body of sand, which has then become the hard structure of the Brigg. And the sandstones don't have much in them, but the limestones sort of above and below, the students here are standing on limestone, there's limestone higher up, they're full of burrows and shells and lots of sort of signs of life. Mostly it's suggesting quite an arid sort of environment, so probably kind of Mediterranean sort of setting, quite a dry summer. And as Rich is pointing out here, the Brigg itself is covered in huge blocks with these amazing thalassinoides trace fossils. So you get block after block of these burrowed, limey sandstones, and here's one that's absolutely riddled in. Again, they've been cast, so you're looking at things that have filled in hollow burrow structures and they're overturned. So it takes a bit of getting your head around it, but these are basically what were navigated by crustaceans, the tunnel network in the shallow seafloor. They've been filled in, and then they are cemented up with something a little bit tougher than the matrix of the rest of the rock. So they weather out as prominent, solid features, and the rest of the rock weathers away. I have colleagues from the US who are like, this is the best place I've ever seen these sorts of traces, but they haven't seen a lot of study, and they're rich for further scrutiny of what kinds of creatures were living in this late Jurassic sea floor. There's lovely comparisons today in the Bahamas. So if you fancy a field trip to the Bahamas, that's the place to go and compare. But there isn't much that's been done. So if you go to Filey Brigg, there's actually glacial structures, there's some glaciotectonic stuff, there's lots of really interesting geomorphology. We have trace fossils, ichnology is the study of trace fossils, we have lots of fossils, sedimentology, there's modern ecology. Nobody much has really been doing anything. So we're trying to persuade more people to come and have a look at the geology of Filey Brigg in the hope of finding out more about what was going on in the Upper Jurassic. So yeah, 200 years on, we've got lots of information in various parts, particularly around Whitby, and I guess with dinosaurs around Scarborough. But in the earliest parts around Redcar, not so much. The later parts around Filey, not so much. And that's plenty of other gaps and interesting locations. So if you're interested in coming up and having a further explore, there's plenty to get your teeth into. We have got a Yorkshire Coast Rocks website now, which hopefully sort of helps people find out what sort of trips are going on, what sorts of things they can do and find out, and links to the Fossil Festival. And yes, I'm going to do an online class in a couple of weeks' time through the University of York Lifelong Learning Programme on the geology of the Yorkshire Coast. So if you do feel inclined to spend 3 hours listening to me talk about rocks on the Yorkshire Coast, you can sign up through the University of York website. And yeah, if you come up to Scarborough, do pop in and see us in the fossil shop or come to the Fossil Festival. There's various websites and so on you can link, and I'll say I'm happy to share email and social media and so on. So if you want to get in touch with anything you're interested in, then we're happy to try and point you in the right direction. Thank you very much.
Questions? Cool. Well, yet again, Liam, thank you ever so much. Shall we thank Liam in the usual way?